Okay, so we're going to use the relationships between distance and speed and a little bit of dimensional analysis, which means basically dealing with the units and canceling things out based on that. So first thing is Linda traveled for 1 hour. And as you read the question, you'll see the word minutes popping up a lot. So we're going to convert this 1 hour into 60 minutes and then go based off of that. So she traveled 1 hour at a speed that resulted in her traveling 1 mile. So she travels 1 mile every day in an integer. Sorry, she doesn't travel 1 mile every day. She travels 1 mile in an integer number of minutes. So the distance that she travels in a set number. So if she takes, let's say, X minutes on the first day to travel 1 mile, then that means she took 60. So I'm going to say 60 minutes times 1 mile in X minutes. So the minutes cancels and it becomes 60 miles, 60 over X miles. And that's the distance she travels on day 1. So I'm going to call that D1. And so if you use the same idea, because it says that the number of minutes increased by 5 minutes since the previous day, we get that the distances are 60 over x, 60 over x plus 5, 60 over x plus 10, and 60 over x plus 15. So there has to be some set of numbers such that, these are all whole numbers. Or these are all integers. And looking at this, you get a sense because, well, if you look at the factors of 60, it's 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30, and 60. So out of these, which of these is increases by 5? So I think, so based on looking at this, it would be 5, 10, 15, 20. And this is the only set in this that, increases by 5 and has 4 terms in it. So that would clearly say that x is equal to 5, and that would lead to 60 over 5 plus 60 over 10 plus 60 over 15 plus 60 over 20, which is equal to 12 plus 6 plus 4 plus 3, which is equal to 18 plus 7, or 25. So the total number of miles for the 4 trips was 25 miles. So it's a little more complicated. And you have to bring in some amount of dimensions, their units, and kind of look about it. But if you can try to solve this question, then you're pretty much set for a lot part of the work time aspect of this test. Okay. The next example, as Emily is riding her bicycle on a long straight road, she spots Emerson skating in the same direction, half a mile in front of her. After she passes him, she can see him in her rear mirror until he is half a mile behind her. Emily rides at a constant rate of 12 miles per hour, and Emerson skates at a constant rate of 8 miles per hour. For how many minutes can Emily see Emerson? So I'm going to give you some time to think about it and try to solve it, and then we'll come back and discuss.